Good evening, everyone. In today's session, we are going to see about supervised learning demystified from theory to code. In this session, we will be bridging the gap between the concepts and the code. And I will be the presenter of today's session. Myself, Akshwan. I'm currently working as R&D engineer, particularly in AI ML domain. So what is machine learning? This is a basic question which is important to understand the whole session. So machine learning is a subset of artificial intelligence where computers are learning the patterns from the data which we give and make the decisions or predictions without explicit programming. And the machine learning is particularly classified into two types, supervised learning and unsupervised learning. And in supervised learning, we have two sections, which is regression and classification. And this particular session, we will be focusing on the supervised learning, and we will be learning what is regression, what is classification, and how we can implement regression and classification in day-to-day use cases. So what is supervised machine learning? It is one of the most widely used foundational subject of machine learning. Supervised learning allows us to predict the outcome based on a given labeled data. It serves as the starting point of many real-world ML projects. So the real-world applications are in healthcare sector, finance sector, marketing sector, e-commerce sector, agriculture sector, and so on. And I've given the examples of each. So the main objective and the goal of the session is to break down the core theory behind the supervised machine learning and demonstrate it using hands-on practical examples in both classification and regression, where we'll be solving a real life problem and we will be using the supervised learning to predict it. So supervised machine learning is a machine learning approach where the model is trained using the labeled data, like I said. So if we consider mathematically, it's a function mapping x to y. So f of x is given equals to y, or y is equals to f of x. X are the input features and Y will be your target features. And F is the model which we are going to train according to our required use case. So like I said, there are two types of machine learning, and among that in supervised machine learning, we have two types. The first one is regression, the second one is classification. So in regression, our objective will be to predict a numeric continuous value, which is basically a real number. But in the classification, we will be having discrete values and we will be classifying them into different classes. So for example, in regression, we will be predicting the house prices, which is obviously a real number, right? And in the classification, we will be classifying two objects or more objects. For example, email spam detection, whether the email is spam or not. So before diving into the core concepts, let's know about some key terminologies. So the first one is features. So what are features? Just the input variables. It can be anything which we are going to input to a particular algorithm or a model. What is labels? It is going to be the output which we wanted to predict or classify. So initially, while we are implementing the machine learning algorithms, there are two procedures. Initially, training, and the second one is testing. So initially, we have to train the model so that the model has learned something from the given data, which is later used for testing. So one more key terminology is loss function. Loss function is a mathematical function which quantifies the error between the predicted and actual output. And there are many metrics for loss functions, but specifically, we will be using MSE for regression and cross entropy for classification. And many metrics are available, which include precision, recall, F1 score. Particularly, these metrics are used for classification purpose. And mean square error, mean absolute error, root mean square error are used for regression problems. So how does the model work? What is the whole workflow? So initially we start with a data collection, then we will be processing the given data because the real world data is noisy, where we'll be handling the missing values, outliers, encoding the categorical variables, normalizing the numerical features. Then we'll be splitting the data into training and testing sets. and so on. Then we will be choosing a machine learning algorithm and we will be training it. So we have huge number of machine learning algorithms. For linear models, we have linear or logistic regression, and we have tree-based models where we have decision tree, random forest. We have boosting algorithms, bagging algorithms, and so many. After we train, we have to test the data, and by evaluating the model, we are testing it. So we again have various evaluation metrics. And once we get a very good accuracy, we will be deploying this model in many platforms like AWS, Azure, Streamlit, and so on. So these are the popular algorithms which we generally use for classification and regression. So linear regression is a algorithm which is particularly used for regression purpose. And the logistic regression is an algorithm which we use for binary classification and decision tree, support vector machine, KNN, random forest, all can be used for both regression and classification based on the modules which we will be inputting. So firstly, the regression problem. So for the live demo, we have selected a predicting house price from a given data set. So in this demonstration, we will be using a simple algorithm, which is linear regression algorithm, and we will be evaluating the model based on these three evaluation metrics. And we will be also plotting the actual and predicted price plot. So we will be able to compare how good our model is able to predict the house price. And I have attached the link of the dataset, the open source dataset from Kaggle itself. So I have already run the code. So let's go through it. So this is the house price prediction notebook, which I have opened in a platform called Jupyter Notebook, an excellent platform to learn and implement machine learning and deep learning models. So the first step is going to be importing the necessary libraries, where we have imported all the required libraries. For examples, I have imported NumPy, which is important for mathematical calculations. I have imported Pandas, which is important for loading the data sets. I have imported Matplotlib, which is important for plotting the data. And we have Seaborn. Again, we have so many good functions in Seaborn. We have imported standard scaler from the sklearn, which is scikit-learn. And we have also included a train test split, which is used to split the data into training and testing samples. And we have imported the key model, which is linear regression from a library called scikit-learn and linear model. And we have also imported the metrics which are used for evaluating the model. So let's load the data. So the path is from Kaggle itself. I have run the complete code in Kaggle platform. Please go and explore the Kaggle. It's an amazing platform for beginners and whomsoever who wanted to become very good with machine learning algorithms or deep learning algorithms or any AI concepts. So we have used a function called read.csv from Pandas to import the data into the system. And we have used df.head. So the head function is used to retrieve top 5 rows from a data set. So this is the first 5 rows of the data set, which has square footage, number of bedrooms, number of bathrooms, year built, lot size, garage size, neighborhood quality, and house price. So house price is our target variable and remaining all other will be our input feature. So let's analyze the data initially. Like I said, head function is used to retrieve the first 5 rows of particular data set. Similarly, tail function is used to retrieve the bottom 5 rows of a data set. The shape function is used to get the shape. So the first value denotes the number of rows and second value denotes the number of columns. We have another function called info, which basically gives the overall information about the data set. So we can see how many rows are there and we can see whether it is a null value or a non-null value column. And we can also see the data type of each columns. Proceeding that, we can have a d types function, which is used to get the data type of particular column. And we can use column function to get the indexes of the particular data set. So I have used a small for loop to get all the columns in each separate lines. And this is a very important function and will be very, very useful while we are data pre-processing in almost every day scenarios. So df contains the data set and we are using the isNull function to get whether is there any null values in the particular data set. And we are using a sum function to sum all the null values in a particular column. So we can see there is no null values. So it's a very good and we can proceed further. So next steps will be data pre-processing and splitting. We have our X, which is an input value where I'm dropping the house price column. So we will be basically having the remaining columns as our input feature, and Y, which will be our target column, will have DF of house price. And we are again using train test split to split the data into training and testing samples. Kindly note the order. It should be X train, X test, Y train, and Y test. It's a very important. Then we are using a standard scaler so that the model will be using the values which are scaled. If you're saying we have scaled separately for X train and X test, we won't be scaling the value for Y. Please kindly note it. We are only scaling for the X values. After that, we can to implement the model. So I'm calling the linear regression function and I'm going to fit. So fit is a synonym of train, but fit is a syntax which we use in TensorFlow. So we are going to fit the model with the X train and Y train. So this function is very crucial where the model will be learning the pattern from the particular data. So it will be mapping X train to Y train. So it learns the pattern and it has a good understanding of it. Then we will be predicting, yeah. For which we will be using a function called predict, and we will be giving X test as the input feature for predicting. So now we have predicted using the linear regression model. After that, we will be continuing with the evaluation of this particular model where we have mean absolute error and root mean square error and R2 scores. So these are inbuilt functions in scikit-learn library itself, which is so adaptable and easy to use. So I'm printing the evaluation metrics and we can see MAE, RMSE and R square values. So if the R square value is approximately equals to 1, the model is very generalized and very good. And this is a small code which has been written you basically using the Seaborn and Matplot library where I have visualized the real data and the predicted values. So the red line which is shown in the diagram is the predicted values and green dots are the original values. So we can see it's pretty much accurate, right? The error will be very less. So let's take this particular point, yeah. So it is very near to the line. So it is really amazingly predicting the output. Yeah. So yeah, this final cell I will be explaining. So we have imported the figure function from matplotlib and we are setting the size and we have used a scatter plot from Seaborn where we have given all the features and the hyperparameters. Then we have used plot function to plot it the way we want our plot to be. We have given X label, Y label and title. And we have also set the grid is equals to true, which means the squares, right? The grid in the graph will be shown. And we have used plot.plt.show to show the graph. So this is an example of a linear regression, which is very important and a very basic example to start learning. So next we will be seeing the classification. So the dataset which we are going to use is for detecting the breast cancer. So the model which we'll be using is random forest classifier, which is an ensembling model, comparatively an advanced model than linear regression. And the evaluation metrics we will be using are accuracy, precision, recall, and F1 score. And we will be also visualizing using the heat map and using Seaborn. And we have also have the confusion matrix, and I will be explaining how to read the confusion matrix. And the dataset has been given And the Kaggle itself, I have given the link in the PPT, which will be shared. So yeah, so this is the notebook where I've implemented breast cancer detection. Similarly, the most of the steps are same. So we are importing all the required libraries. Everything is same except the model is imported from the different libraries, and we have imported the accuracy evaluation metrics as well. So we have load the data from the Kaggle itself, and again you're dropping, yeah. So we are dropping unnecessary columns like ID, unnamed, 32. Yeah, this is of completely null value because the data is noisy. So we are removing unnecessary columns completely. Next, we will be like seeing the head. So just to get an overview of the data set, the columns keeps all the columns in the particular data set, and this important function, like I explained in the previous notebook, if there is any null value, there is no null value, so it is good. We can get the data types from using this syntax and getting the information and the whole describe function. This is a very important function for analyzing the data, particularly speaking. So this comes more of a statistic related function where we will be getting the count, the mean, standard deviation, minimum, one fourth quartile, half quartile, to the third quartile, and maximum values for each column. So analyzing the data set will involve a huge statistical analysis. So this function is very important for that. Next, between data pre-processing and splitting, we are again splitting the data into X and Y. X is input feature, Y is output feature. Then we are using train test split to split the data into training and testing. Again, we are using the standard scaler in the X to standardize the data. Then we are implementing the algorithms. So we have implemented and we have predicted the algorithms as well. And we have got the probability score as well. So these are the evaluation metrics which are used in this. So accuracy, precision, recall, F1 score, ROC score. So all these evaluation metrics are inbuilt. So it is very, very comfortable for us to implement the evaluation metrics. In this example, I have implemented using logistic regression itself, but I have also implemented using random forest classifier, which you can go and see in my Kaggle platform or my GitHub. Yeah. So like I said, I have said that I have implemented random forest in the PPT. I have implemented, but I wanted to show you the basic algorithms, how it works. So if you're going into random forest, we will be having a lot of hyperparameters and you have to tune them. So I'm not complexing it. So I have implemented a simple logistic regression, which is used for binary classification. Don't confuse with the name. It's not a regression. It's an algorithm which is named as logistic regression, which is used for binary classification. So I have evaluated the the model and I've print the accuracy score. So accuracy is about 97%, which is pretty good. And we can get the classification report, which shows very clearly the precision, recall, and effort score. So always there is a tug of war between precision and recall. So should adjust the model hyperparameters so that you approximately get the precision is approximately equals to recall. So yeah, and we have visualizing the confusion matrix. This is very important when it comes to classification. Yeah. So we have used again Seaborn and Matplotlib to plot this. So I'm not going to explain this code. I have explained already, but heat map is a new function which we use particularly for bringing up this particular format of the square with the different colors. Yeah. So how to read this confusion matrix is something which is very important. So in the x-axis we have predicted, and the y-axis we have actual. So you can see this malignant should be mapped to malignant. So 41 cases of malignant are actually marked as malignant by the model, but 2 are marked as benign. So it's just the inaccuracy or the error in the model. Similarly, 70 are marked as benign, which are actually benign by the model. and one is misclassified by the model as malignant. Yeah. So, but the model is performing pretty good for the data set, and we have gotten very good accuracy. And we have an ROC curve. So, receiver operating characteristic curve, which is approximately should be equals to 1 if it is very good. So at least it should be greater than 0.8. Yeah. But we have gotten here AUC equals to 1. So what is AUC? It's area under the curve. So this is the curve, and we will be calculating the area under this particular curve, and the value has come as 1. So which means it is actually doing pretty good. Yeah. So again, we have a false positive rate, true positive rate, and the thresholds equals to ROC curve, which is an inbuilt function. And we have used the figure size, and we have used plot function to plot all this. Have used the X label, Y label, title. So this is an important legend. We have this legend which is used to plot it. Yeah, plot the ROC thing, and we have gotten pretty good. Yeah. So that's it about the implementation part. In real world, we have so many use cases like credit card fraud detection, medical diagnosis, customer churn prediction, stock price forecasting, spam detection, and so on. Yeah. And the conclusion, you can read some books. Yeah. Hands-on machine learning with scikit-learn, Keras and TensorFlow by Audrey and Geron. It's an amazing book. Python for Machine Learning by Sebastian Draska. It's again another important and amazing book. I've given the links for documentation of scikit-learn and the datasets from Kaggle websites itself. So if you're having any question, you can always ask me. And yeah, so no question is too small. Feel free to ask and communicate. The only bad question is the one you don't ask. Yeah. And thank you, and I appreciate your time and curiosity for joining the session. If you wanted to connect me in LinkedIn, GitHub, or email, I have included all the details.